Before a single drum is ever heard, it has to be carried. Right here, in the heart of a traditional Pakistani workshop, two workers begin the process, the only way it can begin, with raw timber and raw effort. These massive logs, freshly delivered, are about to begin a transformation that has been perfected across generations of South Asian craftsmanship. The first tool in this workshop isn't a chisel or a lathe, it's a chainsaw. A worker plants his feet firmly on the log and lets the blade do what no hand tool could, slice through dense, heavy timber in seconds. Each cut is deliberate. Each segment that drops away is exactly the right length for a Dholak drum body. The sawdust flying through the air isn't waste, it's the beginning of precision. This is where rough becomes purposeful. Now the real coordination begins. Several workers move together, lifting the freshly cut wooden blocks and carrying them across the workshop floor. These aren't light pieces. Each block weighs enough to demand full-body effort. They're stacked carefully against the brick wall, sorted and organized for the next phase of processing. There's no conveyor belt here, no automated system, just men working in unison, communicating through habit and rhythm built over years of doing exactly this in exactly this way. Now the work gets technical. The vertical bandsaw, a towering green machine standing at the center of this mechanical bay, is where the raw log begins its first real structural transformation. Two operators take their positions on either side of the machine. One guides, one receives. Together, they feed the heavy log segment directly into the path of the continuously moving blade. What the bandsaw is doing here is called debarking and squaring. The rough outer bark, uneven, organic, imperfect, is being sliced away to reveal the clean, tight-grained interior wood beneath. This wood, light in color and dense in structure, is what gives a Dholak its acoustic integrity. The process demands patience. The operators can't rush the feed rate, push too fast, and the cut drifts. Too slow, and the blade binds. The rhythm they maintain is a result of experience, not instruction. Sawdust cascades down a chute beneath the machine in a steady, almost hypnotic stream. By the time this stage is complete, the once rough log has become a square timber block, 4 flat faces, clean edges, and a surface ready for the next level of precision shaping. The bark, the imperfection, the wildness of the natural tree gone. What remains is raw material ready to become an instrument. A square block cannot become a drum. The lathe needs a cylinder, or at least something close to one. So the workers return to the bandsaw for a second pass. This time, they're removing the 4 sharp corners of the squared block, cutting at precise angles to produce an octagonal cross-section, 8 sides instead of 4. It sounds like a small change, but geometrically it's significant. An octagon is far closer to a circle than a square. When this block reaches the lathe, the machine will have far less material to remove, which means faster turning, cleaner results, and less stress on both the tool and the craftsman controlling it. Before the lathe can spin, the craftsman must find the center. Using a mechanical compass, he marks a precise geometric midpoint on both faces of the octagonal block. This step is not optional. It is not approximate. If the center point is even slightly off, the entire block will spin off balance at high speed, creating vibration, uneven walls, and an instrument that will never sound right. With the centers marked, the block is mounted horizontally onto the heavy-duty wood-turning lathe. The craftsman hand cranks the tailstock mechanism, driving the metal point firmly into the marked center and locking the block in place between the 2 spindle points. One turn of the crank at a time until there is zero movement. Only then is the block ready to spin. This is a scene that separates craft from labor. The lathe powers up, and the octagonal block begins to spin, fast, steady, and with a sound that fills the entire workshop. The craftsman picks up his gouge chisel, a long, heavy steel tool with a curved cutting edge, and braces it against both the tool rest and his own body. He is not just holding the chisel, he is becoming part of the machine. As the spinning block meets the chisel edge, wood begins to peel away in thick, curling ribbons. The octagonal shape starts to disappear, corner by corner, rotation by rotation, replaced by the smooth, continuous curve of a true cylinder. This process is called exterior turning, and it requires the craftsman to read the wood as it spins. He watches for inconsistencies in the grain, adjusts the angle of the chisel, varies the pressure, moves laterally across the tool rest to maintain an even profile from one end of the block to the other. There is no digital readout telling him the diameter, no automated depth stop. He is working by eye, by feel, by the sound of the cut, and by the texture of the shavings coming off the blade. Fine shavings mean a light cut, a finishing pass. Thick ribbons mean aggressive stock removal, getting the shape close before refining it. The workshop floor disappears under a growing layer of golden wood shavings. The smell of fresh cut timber fills the air, and the block, which arrived at this station as a rough octagonal piece of lumber, is becoming something unmistakably different. It has a waist, a profile, a shape that the craftsman's hands are pulling out of the wood, one deliberate pass at a time. Once the turning is complete, the craftsman reaches for a sand block, an abrasive sheet wrapped around a firm backing. He holds it against the still spinning drum body, and the lathe itself does the sanding. The surface that was already smooth becomes smoother, then smoother still. What started as raw forest timber is now a perfectly turned wooden cylinder, uniform, balanced, and ready for decoration. The transformation from nature to instrument is well underway, and we are only halfway through the process. Now the craftsman shifts from structural work to aesthetic work. The drum body is still mounted on the lathe, still spinning, and he is going to use that rotation to apply the decorative finish that makes Pakistani Dholaks immediately recognizable anywhere in the world. Using a specialized edge tool pressed against the spinning surface, he burns or carves precise, narrow grooves into the drum shell at regular intervals. Into these grooves, he applies a dark pigment or inlay material, creating clean, evenly spaced decorative bands that ring the entire circumference of the drum. Because the drum is spinning as he works, the lines are mathematically perfect, no ruler required. The rotation is the ruler. Next comes the lacquer. Applied in controlled passes against the spinning surface, the liquid finish soaks into the wood grain and begins to build up a protective, high-gloss coating. The craftsman works the lacquer evenly from one end of the drum to the other, watching the sheen develop under the workshop lighting. With each additional coat, applied and polished while the drum rotates, the surface goes from matte to satin to a deep reflective gloss. The finished pattern is striking. Alternating bands of dark brown decorative lines and the natural golden tone of the wood create a visual rhythm that mirrors the rhythmic function of the instrument itself. Under direct light, the lacquered surface reflects like polished glass. Run your hand along it and you feel nothing but smoothness, no grain, no texture, no imperfection. This stage of the process is often overlooked in discussions of drum making, but it is not cosmetic. The lacquer seals the wood against humidity, critical for an instrument that will be handled constantly, played outdoors, and exposed to the variable climate of South Asia. The decoration and the protection are applied in the same step, by the same hand, using the same rotation that turned the raw log into a cylinder. Efficiency and artistry, working together on a spinning axis. Everything built so far, the squaring, the turning, the finishing, has been about the outside of the drum. Now comes the step that determines everything about how it will actually sound. The craftsman must hollow the interior. A dholak is not a solid cylinder. It is a resonance chamber, a carefully engineered hollow shell, whose interior dimensions directly control the depth, warmth, and projection of its acoustic output. Too thick, and the drum sounds dead. Too thin, and the shell cracks under tension. The craftsman must remove exactly the right amount of material from inside the drum, and he must do it blind, working entirely by feel and sound. The tool for this job is unlike anything seen in the exterior turning stage. It is a long sword-like iron auger, a massive boring tool that extends deep into the interior of the spinning drum shell. The craftsman mounts it into the lathe assembly and begins driving the cutting edge inward into the core of the wood. The physics of this operation are demanding. As the drum shell spins and the auger cuts deeper, the forces involved increase dramatically. The craftsman must brace the tool against his body and the tool rests, controlling the depth and angle of the cut with his arms, his shoulders, and his core. The vibration traveling back through the metal tool into his hands gives him information about the density of the wood at that depth, about whether the cut is running clean or beginning to chatter. Wood dust evacuates from the hollow in high volume bursts, blasting out from the open end of the drum directly toward the camera in a continuous stream. What is coming out of that shell is not just waste material, it is the negative space that will define the instrument's voice. Every cubic centimeter removed from the interior is a decision about acoustic character. The craftsman works in passes, driving the auger to a certain depth, withdrawing it, clearing the waste, then driving it deeper. He is boring through solid wood one layer at a time, building a hollow that runs the full internal length of the drum body. The goal is consistent wall thickness from one end to the other, typically somewhere between 12 and 20 millimeters depending on the size and intended tuning of the drum. This process takes time, nearly 3.5 minutes of focused, physically demanding work at the lathe. The pile of fine internal wood waste accumulating on the floor grows larger with every pass of the auger. The workshop fills with the sharp, clean smell of freshly cut timber interior, a different smell from the exterior turning, lighter and more resinous, because the auger is cutting into heartwood that has never been exposed to air before. As the hollowing nears completion, the craftsman begins to slow down. The final passes are lighter, refining the interior surface rather than removing bulk material. He is listening now as much as he is feeling. The sound of the lathe changes slightly as the walls become thinner. The vibration pattern shifts. These subtle signals tell him when to stop. There is no digital caliper running inside the drum measuring wall thickness in real time. There is no computer generating a cross-sectional profile. There is a craftsman, a spinning piece of wood, a cutting tool, and decades of accumulated knowledge about exactly what this process sounds and feels like when it is being done correctly. That knowledge cannot be downloaded. It cannot be automated. It lives in the hands and ears of the person running this machine, and it is the single most important technical skill in the entire Dholak making process. When the auger is withdrawn for the final time and the lathe is powered down, what remains on the spindle is no longer a block of wood. It is a drum shell, hollow, resonant, and ready to become a musical instrument. The craftsman dismounts the finished shell and lifts it to eye level. He rotates it slowly, running his fingers along the rim, then peers directly through the hollow center, checking the wall thickness visually from both ends. This is quality control Pakistani workshop style. No instruments, just experienced eyes and hands. The shell has passed inspection. Now it moves to the hardware installation phase, and the environment shifts noticeably. The craftsman moves from the dusty, heavy machinery bay to a cleaner indoor assembly room with tiled flooring. The noise level drops. The work becomes precise in a different way. Sitting cross-legged on the floor, the traditional working posture of South Asian craftsmen. He picks up a hand drill and begins making a series of evenly spaced holes around the exterior rim of the drum body. These holes must be perfectly positioned. They need to be equidistant from each other and from the rim edge, because they will carry the tuning hardware that controls the tension and therefore the pitch of the drum heads. Once the holes are drilled, the hardware goes in. Metal bolts are inserted through the rim holes. Decorative washers are added, both functional and aesthetic, distributing the tension load and adding a finished look to the hardware line. Then come the tuning hooks, the classic curved metal lugs that will eventually engage with the hoop rings and draw the drum heads into tension. Each lug is positioned, inserted, and tightened with a screwdriver. The craftsman works around the drum methodically, not rushing, not skipping steps. The metal hardware against the high-gloss lacquered wood creates a striking visual contrast. Industrial precision meeting artisanal finish, the drum is beginning to look like what it is, a professional musical instrument. This is the final major assembly stage, and in many ways the most critical. The drum heads are going on. From this point forward, the acoustic character of this Dholak is fixed. The craftsman begins by inspecting the pre-cut circular drum heads, called puri in the traditional terminology, made from raw animal skin. These are the membranes that will vibrate and produce sound. Their quality, thickness, and condition directly determine how the finished drum will perform. He selects the appropriate heads for both the bass end and the treble end of the drum. On the bass drum head, he applies the siahi, the black acoustic patch, made from a paste of iron powder, flour, and other traditional materials pressed and shaped into a precise circular disc at the center of the skin. The siahi is not decorative. It adds mass to the center of the membrane, which lowers the fundamental resonant frequency and gives the bass head its characteristic deep, warm tone. The exact composition and application of the siahi is one of the most closely guarded technical details in traditional Dholak manufacturing. With the siahi applied and tempered, the craftsman submerges the drumhead in a bucket of clean water. The soaking makes the animal skin pliable, soft enough to stretch over the drum opening without cracking, but with enough structural integrity to hold tension once it dries and contracts. He pulls the wet skin from the water and positions it over the open end of the drum shell, aligning it carefully so the membrane sits centered over the opening. A steel hoop ring, the counter hoop, is placed over the skin and seated against the drum rim. Now comes the tensioning work. The craftsman pulls the edges of the wet skin down over the hooks, working around the drum in a star pattern. pulling one side, then the opposite side, then rotating 90 degrees and repeating. This cross-tensioning technique ensures that the skin seats evenly across the entire rim with no high or low points. He uses a wooden mallet to strike the counter hoop, driving it down and setting the tension incrementally as he works around the drum. The sound of the mallet on the iron hoop, a sharp metallic ring, tells him how the tension is distributing. An experienced ear can hear the difference between even tension and a drum that needs adjustment. He listens and responds, working the hoop down until the fundamental pitch is correct and the tone is even from every striking position. Finally, with the head seated in tension, he draws a sharp knife along the rim and slices away the excess skin overhang in a clean, continuous cut. The edge is now flush with the rim, clean. Finished, he repeats the entire process on the treble end, adjusting the tension there to produce the higher pitch, tighter tone that the treble head requires. 2 heads, 2 pitches. 1 instrument, now acoustically complete. The tools go down. The craftsman positions the completed Dholak across his lap, raises both hands, and plays. A rapid, rolling folk cadence fills the finishing room. Bass notes from the left hand, sharp treble strikes from the right. The drum responds immediately. The tone is full, resonant, and balanced. Weeks of skilled labor, compressed into the sound of a single rhythm. And this is what it all leads to. Row after row of completed Dholaks, lacquered, strung, and ready. Alongside them, tabla sets, nickel-plated variants, percussion pieces of every size. Each one started as a raw log in a loading bay. Each one passed through the same hands, the same machines, the same process. Pakistani craftsmanship built one drum at a time,